Hello everyone, today is day 7 of solving a LeetCode problem every day. So a little pat on my back for hitting my first milestone, which is my first week. But anyways, the problem we are solving today is called products of array excluding self. So this is a medium problem. Given an integer array nums, return an array output where output I is the product of all elements of nums except nums I. So each product is guaranteed to fit in a 32-bit integer, and a follow-up question is, could you solve it in O of n time without using the division operator? So for the first example, the array we were given was nums equals 1, 2, 4, and 6. So the output for this is going to be 48, 24, 12, and 8, because for this very first position, it is equal to 2 times 4 times 6, which is 48. The second position is equal to 1 times 4 times 6, which is 24. And then this third position is going to be equal to 1 times 2 times 6, which is 12. And finally, this last position is going to be equal to 4 times 2 times 1, which is 8. So I actually have 3 solutions for this problem, and I'm going to go over every single one of them. So the most intuitive approach to this might be to loop through all the elements in this array, then multiply all the elements out except the current element that you're at. So what I mean by that is in the first iteration, what we're gonna do is we're gonna be at index 0. So we wanna multiply out everything in this nums array without including what's at index 0. So in this case, in the first iteration, it's gonna be b times c. So then we're gonna put that in the 0th index in the output array, so b times c. And then for the second iteration, our index is going to be 1. So we want to multiply a and c and put that in the first index. And then for the third iteration, our index is going to be 2. So we want to multiply out a and b and put that into our output array. So while this is a pretty intuitive solution, it isn't a good one. And the reason why it isn't a good one is because to do this, we need to have a nested for loop. And the time complexity of this is going to be O of n squared, which is quadratic time complexity. So we got to find something that is a little more efficient. So this is what the second approach might be. What if we were to create an output array where every single element in this output array was the product of all the elements in nums? So what I mean by that is the product of all elements in nums is equal to a times b times c. And then what we're going to do is put a times b times c in each of these indexes in the output array. What we can then do is divide each of these elements in the output array by the corresponding element that's in the nums array. So what I mean by that is that index 0 in the nums array, we have an a, so we want to divide a, b, and c by a. At index 1, we have a b, so we want to divide a, b, and c by b. And at index 2, we have a c, so we want to divide a, b, and c by c. And now what's going to happen here is we're going to get some cancellations. So a is going to cancel out the a, b is going to cancel out the b, and c is going to cancel out the c. The resulting output array is going to look like this. In each element in this output array, we are multiplying everything but the value at the current index from the nums array. So we are getting the product of everything but itself. Now the problem with this solution is there's actually a follow-up question, if you guys remember before, and it was how can we solve this problem without using a division operator? So while this problem can be solved in linear time, we are doing this using a division operator. So we got to find another solution that works in linear time but doesn't use the division operator. So if we are given this input array a, b, and c, what I'm going to do is formulate an output array where at the very first index it's going to start with a 1, and then this next index is going to be this previous index multiplied by the very first index here. So 1 times a is equal to a. And then at this very last index, so index 2, we're going to multiply the previous index in this output array by the next index in the nums array, which gives us AB. What we are then going to do is do the same thing but backwards. So we're going to leave AB as it is since we're going to basically just multiply that by 1. Then what we're going to do is we're going to multiply this index right here by the last element here. So that's going to be C. So we're going to multiply A times C. And then what we're going to do is multiply this current product by the next or the previous element in this nums array. So we're going to multiply C by B. And then we're going to go backwards here and multiply this index by C times B. So in the end, we're going to have an array that looks like this. So as you can see, in each element, it is the product of all the elements but itself within the array. So the time complexity of this algorithm is also going to be linear time. And the reason why it's going to be linear time is to process this output array twice. It's just going to be n plus n, which is 2n, which averages out to just O of n. So this is what my solution will look like in code. So the first thing we're going to do is create this output array. So to create this output array, it's just going to consist of ones pretty much. So it's going to be ones, and the number of these ones is going to be the length of this nums array that we're going to be given. So now what we're doing next is we're looping through all the elements in num starting at index 1. And what we're going to do is multiply at this current index. We're going to set that to the multiplication of the element at the index before multiplied the element in the nums array at the index before that. Next, we're just going to grab the last element within the nums array since we're going to use that to process the output array again. So what we're going to do next is we're going to loop through the array backwards, starting at the second to last index. And then what we're going to do is multiply the second to last index by the very last number. And then we're going to update this last number to also include the product of the last number itself with the current element in the nums array at this index I. Finally, what we're going to do is just return the output. So like I said before, the time complexity of this is O of n. And the reason why it's linear time is because we just have 2 for loops in here. So each of these are going to take n iterations, and that's just going to average out to linear time complexity. So yeah, that's my solution for today.